Doing a second video on rotational dynamics, and we have a problem of a 1.5 kilogram block is connected by a rope across a 50 centimeter diameter 2.0 kilogram frictionless pulley. A constant 10 newtons tension is applied to the other end of the rope. What is the magnitude and acceleration of the block? Okay, this is what is a picture of what's going on and written down what was given to us, and we have a block that's being pulled over a solid disc with the tension of 10 newtons. And over here I drew a free body diagram of the block and the pulley, and assuming this is the x direction and this is the y direction, we have on the block we have forces of gravity and the force going upward is the tension. And for the pulley, we have the tension is going down this way and the 10 newtons force going this way, and doing counterclockwise is in the positive direction. And since this is a solid disc, it has inertia, and that equation is 1/2 times the mass of the pulley times the radius squared, which we'll use later. And now we're going to use Newton's second law, and for the block we have F net y equals mass times the acceleration of y, which is T minus the force of gravity equals the mass of the block times acceleration, and we're going to solve for T, which is tension, equals the mass of the block times acceleration plus the mass of the block times gravity. And then for the pulley we have the sum of the tension equals the inertia times alpha, which is TR tension minus the radius times 10 newtons equals 1/2 times mass of the pulley times the radius squared. And then since the tangential acceleration of the point on the outside of the rotating object is related to the angular acceleration of the object, we have acceleration equals negative since it's pulling this way in the negative direction clockwise times the radius. And so we're going to combine all of these equations and we get R times mass of the block times acceleration plus the mass of the block times gravity minus the radius times 10 newtons equals 1/2 mass of the pulley times radius squared minus negative acceleration over the radius. And then we solve for A, and down here we get R times the 10 newtons minus mass of the block times gravity over the mass of the block plus 1/2 times mass of the pulley. We plug in the numbers and you get 0.25 meters times 10 newtons minus 1.5 kilograms times 9.87 meters per second over 1.5 kilograms plus 1/2 times 10 times 2 kilograms, and we get negative 1.88 meters per second squared is the magnitude and acceleration of the block.